Yeah. So, good people, let's understand each other. Let's understand each other. Remember, this side, I said the expected value of y is what? Is theta, because there's a theta here. And the variance of y is what? Is theta squared. What about this side? This side, the expected value of y is beta. And the variance of y is beta squared. Why am I saying this side is theta, but this side I'm saying beta? Remember here, they are giving you, what is it, 1 over theta, e to the power negative y over theta. There's a theta, there's a theta. So there's a theta here, there's a theta here. So the expected value is theta. This side, there's a beta, there's a beta. The expected value is beta. What about if I write it like this? Y is equals to maybe 1 over, let's say theta, or a theta over n, e to the power negative y over theta over n, then 0, y greater than 0, then elsewhere. Let me put it like this. So if I were to ask you what is an expected value of this guy here, the one that I just wrote here, what is this expected value? Remember, here is theta over n. Here also it's also theta over n. So it means the expected value here of y is just theta over n, and the variance of y is just theta squared over n squared. You see? So let's come again. If it was like this, it was f of y is equals to 2 over n e to the power negative 2y over n. So y greater than 0, then 0 elsewhere. So what is this? What is the expected value? We want the expected value here and also the variance of y. So what is the expected value here? Remember, it has to be 1 over something. That something, it will be what? The expected value. So to make this thing to be 1 over something, remember 2 over n can also be written as 1 over n over 2. That's the same thing. 1 over n over 2 is the same as 2 over n. They're the same thing, like 2 over n. And this side also is the same thing, because when you solve, it will 1 divide by n over 2. What is n over 2? Then you can multiply 1 by what? By 2 over n. Then when the answer is 2 over n. You see, they're equal. So it means this distribution, you can turn it to what? You can turn it to like 1 over n over 2. 1 over n over 2 e to the power negative y over n over 2. Then y greater than 0, then 0 elsewhere. This is how it is. Then the expected value of that guy, that's where it can be what? It can be n over 2. The expected value, it's n over 2. Then what about the variance? It's n squared over 4, because it's just the square of the expected value. So let's look at these examples in the textbook. So let's look at these examples. Remember, here you are given an exponential here. So what is an expected value of y? It's what? It's theta. What is the variance of y? It's what? It's theta squared. Then what about this first question? This first question here. So they're saying the expected value of theta 1 is just the what is it? It's just y1. What about this guy? So we said the expected value of this side is equals to the expected value of this side. So what is the expected value of y? It's what? It's theta. So you see where it's unbiased. Hence I'm saying identify the statement. Before you can answer the question, identify the statement so that you can know which one to substitute where and which one to substitute where. So let's do it like this. Where is that thing? When they are talking about mu, is it time up? Oh, sorry. So when they are talking about mu and when they are talking about mu and when they're talking about mu and the sigma squared, they're talking about the normal distribution. So they will say mu and theta. It means the expected value of y is just mu, and also the variance of y is just sigma squared. So it's a normal distribution where it was derived from what? From mu and what? And sigma squared. It's mu and sigma squared. So it's normally distributed. It's a normal distribution. So you just have to know these things. And also, what about 9.4? 9.4, it's a uniform distribution. You can see they're saying it's a uniform distribution. So if it's a uniform distribution, what is an expected value of a uniform distribution? It's theta 1 plus theta 2 all over 2. So the answer is 2 theta plus 1 all over 2. That's the what? The expected value. What about the variance? Theta 2 minus theta 1. So it's 1 over 12. Because it's theta 2 minus theta 1 all squared divided by what? By 12. So when you do theta 2, which is theta plus 1, theta plus 1, you minus 1, then you square, and you divide by 12, you'll get 1 over 12, because the theta will cancel with the theta. 1 over 1 to the power 2 is just 1. So hence I'm saying, like, always identify the statement before. Identify the statement. If the statement is given by whatsoever, like normal distribution here, 9.5 also, they're saying normal distribution. So it means here, when you want to prove, you will use something that we call a normal distribution. So also this side, you can prove this guy here. They're saying normal distribution. It means where you see the expected value of y, you'll put what? You'll put a mu. Then when you see the variance of y, you'll put what? Sigma squared. So hence I'm saying identify the statement. And also here, 9.3 they're saying it's what? Exponential. What is an expected value? Theta. What is the variance? Theta squared. Let's go down. Hence I'm saying, like, identify the statement. You see, if you can do these 3 questions, look at the example. The statement, it was what? Uniform distribution. Here, it was uniform distribution. Then what is an expected value of a uniform distribution? What is that expected value? It's this guy over 2, so it's theta over 2. So that theta over 2, we'll put it where there's an expected value of this guy here. You see? So we'll put theta over 2. Then that's where it's what? It's biased. It's unbiased. Then what about this function? What about this function, the new function that they created here? This function. What about this function? Looking at this function, you don't know the name of this function. Hence why when you want the expected value, you'll do what? You'll find the expected value of that yn, then you'll put the integrals. Hence I'm saying, like, if you don't know the distribution, that's where you'll put the integrals. But if you know the distribution, use the properties. So yeah, going down, you'll just look at the statement. So look at the statement, identify which one is it. Here, what are we going to substitute? Hence I'm saying, like, you just have to know what are we going to substitute. Then you're done.